Hello, now we're going to do problem 3.1.5.11, which is household income of Burbank, California. The U.S. Census provides data on the number of households by income categories for many geographies. The 2014 data for Burbank, California are provided. We're going to find the following. 1, the weighted mean and assumptions you may make to calculate the weighted mean. And 2, the modal class. Okay, let's start finding the weighted mean. Notice column A has income categories. For example, there's approximately 2,000 households in Burbank, California with incomes less than 10,000. There are another 2,000 household incomes with incomes between 10,000 and 14,999, and so on. There are a total of 41,414 households in Burbank, California, even though the population is about 100,000. A household is a group of people that live in a housing unit. With the average household size being between 2 and 3 in the US, the number of households will always be less than the population. To calculate the weighted mean, we need one specific numeric value for each income category in order to make mathematical calculations. So we will put a label in column C called income. Label column E assumptions. And we will briefly explain how we assume the income for each category. We will also add another label in the row above the labels, row 6, with more generic terms. Column A is the class name. Column B is the frequency. Column C is the value. And we will wait on column D. Let's start with assigning an income to the 10,000 to 14,999 category. A reasonable value would be the middle value, which is about $12,500. That may be apparent to you, or it can be calculated in Excel by entering equals, open parenthesis, 10,000 plus 14,999, close parenthesis, divided by 2. Note that because of the order of operations, if I don't include the parentheses, Excel would first divide 14,999 by 2 and get 7,499.50 cents, and add that to the 10,000 to give a value of 17,499.50 cents. With the parentheses, Excel adds 10,000 plus 14,909 first to get 24,999, and then divides by 2 to get 12,499.5, which is the answer we want. This value, 12,499.5, is the middle. So we will put the middle in the assumption column. It is our best guess. Every household is not making $10,000 or $14,999, but an even spread across the income range is a reasonable guess. Then 12,499 would be the middle. This is a reasonable estimate. For the 15,000 to 24,999 row, the middle can be calculated as equal, open parenthesis, 15,000 plus 24,999, close parenthesis, divided by 2 to get 19,999.5. We will also put the middle in the assumptions column. Note that autofill recognizes that you typed that phrase in before. So if you hit the tab or enter key, it will autofill for you. Frequently, the data intervals are consistent. That's not really the case with this data set, so we will calculate the middle for each category. For the 25,000 to 34,999 row, the middle can be calculated as equal, open parenthesis, 25,000 plus 34,999, close parenthesis, divided by 2 to get 29,999.5. For the 35,000 to 49,909 row, the middle can be calculated as equal to, open parenthesis, 35,000 plus 49,999 divided, close parenthesis, divided by 2 to get 42,499.50. For the 50,000 to 74,999 row, the middle can be calculated as equal to, open parenthesis, 50,000 plus 74,999, close parenthesis, divided by 2 to get 62,499.50. For the 75,000 to 999,000 row, the middle can be calculated as equals, open parenthesis, 75,000 plus $99,999, close parenthesis, divided by 2 to get 87,499.50. For the $100,000 to 149,999,000 row, the middle can be calculated as equal, open parenthesis, 100,000 plus 149,999, close parenthesis, divided by 2 to get 124,999.50. For the 150,000 to 199,000 row, the middle can be calculated as equal to 150,000 plus 199,999, close parenthesis, divided by 2 to get 174,999.50. The two most difficult categories are the less than 10,000 category and the 200,000 or more category. The middles are not apparent for these categories. Let's look at the less than $10,000 category first. The minimum value is 0, so most conservatively, we could calculate the middle as equal, open parenthesis, 0 plus 9,999 divided by 2 and get 4,999.50. However, there's less likely to be an even spread between 0 and 10,000, so the value is likely higher. We just don't know. Once we finish our calculations of the weighted mean, we will determine how much this estimate affects the weighted mean. For an assumption, I will put the minimum income is $0. Now let's look at the final category, $200,000 or more. We have no upper value to average. We know that some people can be making close to $1 million per year. This data can be very skewed, but will only be a few people. So let's guess 400,000 as our value. For assumptions, put guessing and estimate of 400,000. Remember, this is an estimate. Now we've turned our income categories or class names into a numeric value or income. This lets us start calculating the weighted mean. First, we need to calculate the income earned by all the people in each income category or class name. We'll do the calculations in column D. Our generic label will be frequency times value. And a more specific label will be total income. For the less than 10,000 class, we assume that each of the 2,112 households earn $4,909.50. The total income all those households earn is calculated by multiplying 2,112 by 4,909.50. So enter equals, and then cursor over to the 2,112 value, enter times, and then cursor over to the 4,909.50 value. When you press enter, you get 10,588,944. Now that we have the formula, we can copy and paste it down. Go on to the cell and press Control-C. Where there's a flashing cursor indicating the cell has been copied, hold down the Shift key and down arrow until you get to the 200,000 or more row. Then press Control-V for paste. Note that you can also right-click to do the copy and paste. Now we know how much income was earned by all the households in each income category. Next, we need to calculate two totals. So put total in cell B19 to remind us that we calculated in this row. We first want to calculate the total number of households in Burbank, California income categories. Type equals sum, open parenthesis, arrow up to cell B18, hold down the Shift key and use the up arrow to select up to the less than $10,000 category. Our total is 41,414, which verifies the category frequencies sum up to the total number of households in Burbank, California, calculated by the U.S. Census Bureau in row 8. As a professional, your work is rarely checked, so learning self-checks is very useful to catch errors before reporting results to your boss. This is one of those quick self-checks. If we got a different number than the total, then I would start troubleshooting to determine the error. We also need to find out how much income all the Burbank households earned. Type equals sum, open parenthesis, arrow up to cell D18, hold down the Shift key and use the up arrow to select up to the less than $10,000 category. In 2014, they earned a total of almost $3.8 billion. The final step is to calculate the weighted average, is to divide the total income that all households earned by the total number of households. Put equals, arrow up to the total income, enter divided by, and then arrow over to the total number of households in Burbank. Press enter, and the result is $91,339. And that's how we calculate the weighted mean. Our assumptions were basically taking the middle value. The estimates for the first and last categories are more of a guess. If I decrease the assumed income for the last category from 400,000 to 300,000, the weighted mean decreases from 91,000 to 85,401. So with income data, which tends to be highly skewed by a few high income households, this estimate can have a relatively large effect on the weighted mean income. If I change the value of the lowest category from $4,909.50 to $7,000, the weighted mean increases from 91,339 to 91,501. The change is small, so whatever I estimate for this category is not going to matter very much. Finally, let's determine the modal class. The modal class is the class name for income category with the highest frequency. The highest frequency is 6,916, which is for the category 50,000 to 74,999. So our modal class is 50,000 to 74,999. We looked at two ways of finding averages, the weighted mean and the modal class. In this example, the weighted mean does not fall within the range of the modal class. Income data tends to be positively skewed. So in terms of understanding the city of Burbank, the modal class is probably a better representation of the average income of the city. That is how to solve problem 3.1.5.11.